Engineering alone does not make direct-to-device possible. A satellite can have the aperture, the power, the processing, and the orbit, and still be unable to say a word. Because it is not allowed to. Spectrum is not governed by physics. It is governed by treaties, regulators, and licenses. So every D2D transmission depends on two independent conditions. It has to be technically feasible, and it has to be legally authorized. The first 7 lectures were entirely about the first condition. This one is about the second, and it is not the lesser of the two. A perfectly functioning satellite system cannot legally operate on frequencies it has no authorization to use. Start with why D2D uses ordinary cellular spectrum. A smartphone can only transmit on bands its own hardware supports. Antennas, filters, duplexers, power amplifiers, low noise amplifiers, and the RF transceiver are all tuned to a predefined set of bands. If satellite operators used brand new spectrum allocated exclusively to satellite services, manufacturers would have to redesign the handset. And that would destroy the single greatest advantage of D2D, compatibility with billions of phones already in circulation. So the choice is deliberate. The spectrum is not selected because it suits satellites. It is selected because existing smartphones already support it. And that pushes the engineering burden exactly where the previous lecture said it goes. Away from the handset and into the satellite and the infrastructure around it. Which creates the next problem. Those frequencies are already licensed to terrestrial mobile operators. A satellite cannot simply start transmitting on them. So regulators build the legal mechanisms that let satellites reuse terrestrial spectrum under controlled conditions. Implementation varies by country, but the principle is remarkably consistent. The mobile operator keeps primary rights over the spectrum, and the satellite operates as an extension of that terrestrial network rather than as an independent spectrum holder. That cooperative model pays 4 ways at once. Existing smartphones stay compatible because nothing about the band changed. Mobile operators extend coverage without building a single additional tower. Satellite operators gain immediate access to smartphone-compatible spectrum, and regulators keep centralized control over interference management. Terrestrial and satellite stop being competitors for the same spectrum and become two parts of one system. Making that work needs an explicit framework defining when, where, and how satellites may use cellular frequencies. National regulators write those rules. The clearest example is the United States, where the Federal Communications Commission introduced supplemental coverage from space in 2024. Rather than allocating new spectrum to satellite operators, it lets them reuse existing terrestrial mobile spectrum through formal agreements with licensed operators. That gives regulatory certainty while preserving the rights of current license holders. Then there is the border problem. Engineering does not recognize national frontiers. Radio regulation does. A single LEO satellite may overfly dozens of countries in one orbit, and every one of them holds independent authority over spectrum licensing and market access. So global coverage does not mean global service. Each country may require separate authorization before commercial service is permitted in its territory. The ITU provides the international framework through the radio regulations and the World Radio Communication Conferences. In practice, that is why operators do not chase independent global spectrum rights. They partner with existing mobile operators, country by country, using spectrum those operators already hold, together with the regulatory authorization and the customer relationships that come with it. This has become the dominant model for first-generation D2D, and it is likely to stay that way. And that closes the series. Regulation is not a footnote to the engineering, it is the second half of it. D2D reuses cellular bands to keep handsets unchanged. Satellites reuse them as an extension of terrestrial networks, with the operator keeping primary rights. Global coverage is not global service. Direct-to-device succeeds only when engineering and regulation evolve together